Okay, let's take a look at a very typical question seen in trig classes that teaches the law of sines or the law of cosines. And basically, this question is going to entail, they call the non-specific case or something. I can't remember exactly the wording for it, but it's the problem where when you're creating your triangle, you actually have two options for the third side, which will then, of course, create two different options for the interior angles and all sorts of stuff. So you basically have to solve this thing twice. First thing you always want to do is give yourself a picture so you can kind of see what's going on. And in the case of this one, we have the horizon, right? And we have a hillside that creates an angle of 25 degrees. And then you have this tree that's growing vertically on this hillside. And so we can figure out what this angle is, right? If this is a 25-degree angle and this one is perpendicular to the horizon, we can then figure out that, dot, 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 there'd be 25 right here, and then this would be the leftover from 90, right? So that's how we would get 65 degrees there. And then this is going to be, according to the thing, we're going to attach a rope up here at 30 feet tall, and we're going to have a 29 foot cable, which seems impossible, right? Because it's less than the 30, but we have a slope here. So the ground is getting closer. So what's going to happen is you're going to have two options. You're going to have a cable that's close, or the cable will hit far away. And if you kind of visualize having a 29-foot pendulum, it would, swing something like that from this point. And these are the 2 points that it would intersect the hillside, so to speak. So because of that situation, it creates two different types of triangles. And so we have to solve each one individually. So then what I would suggest is kind of redraw those triangles so that you could, visualize each one that's going on. Again, to just help your mind's eye figure out what's going on. So here's our first option, right, of the bigger one. And this is still 30. This is still 65. This is the cable, right? So this is 29. And then we don't know anything else. So we can see that this is the scenario where we have side-side angle. And the side-side angle is always the non-determinate, I think is what they call it. But it's the one, ambiguous, that's the word I'm looking for. It's the ambiguous case because there can be two options. Okay, so we've got that case, right, that scenario, that picture. But then we also have this one over here where it's going to be closer. Sorry, that kind of looks like a 90, but it's not, right? 65, that's a 30, and that's a 29. And then we have to solve that one. And maybe I'll rewrite that so it doesn't look so much like a 90. Something more like that. There we go. 65. Okay, but again, also a side-side angle. And we can call this angle A, right? This would be angle B. This would be angle C, which would make this side A. This is side C, and this is little side, B. And same thing over here. I'll call this angle A, angle B, angle C. So that makes this side A, side B, and this is side C. Well, we have an angle and a side, right? We have, even though we have side-side angle, we have an angle and a side. We have a pair. So we can use the law of sines. We don't have to use the law of cosines with this one. The law of cosines is, kind of the one that we default to if we can't use law of sines, because we always want to try and use law of sines because it's easier and it's just easier. It's a little bit more accurate as well, but really more, it's just easier. But in any case, if we have a pair, if we have a matching pair of a side and an angle, and then we just need one other piece of information, right? We need one other angle or one other side, then we get 3 of the 4 pieces of the law of sines, and we can use it. So in this situation, we can use it for both. So let's say we've got angle, side, and then we've got side. So that means we can solve for this paired up angle, right? We can solve for angle C. So we know that sine of C, the thing we're looking for, over its side of 30 is going to equal the other ratio, right? Sine of 65 over 29. Or, right, to solve for sine of C, just equals 30 sine of 65 over 29. And of course, C is going to be the inverse sine of this number, 30 sine 65 over 29. Stick that in your calculator and get an answer, and then it's going to be decimals, right? You're not going to get a nice, pretty whole number. Then you're going to go back and solve for side B, because once you know this angle, then of course this is just 180 minus it. And then you'll reset the process. Again, use this ratio pair when you then calculate the other one. So the second one is going to be set up, right, with this equaling this set, right? And you'll have sine of b over little b. And you'll know what this one is. You'll know the angle. And you'll need to find b. Obviously, you got to do some cross multiplying to get rid of this fraction the way it is. Or you can, remember with the law of sines, you can set them up in either way. So you could have started this way. Sine of 65 equals b over sine b. And then you know what sine b is, right? So you would have multiply this over here, and that would give you a little b. And then you have all the bits and pieces. You know everything you need to know. Because they're asking for the distances. So this will finally give you the distance b. So it's kind of a two-step process. This one, done exactly the same way, right? You've got a pair, you've got an angle and a side, then you've got another side, so you can solve for this angle. Once you have this angle, then you know this angle from the 180 minus, the sum of those two. Then once you have that angle, you can set it up the same way. Little b over sine of the angle we just found, right, is going to equal, and again, you want to go back to the one that has nice, pretty, perfect numbers. You don't want to use this angle because it has a decimal that you have to round at some point, and when you round, of course, you introduce errors into the new equation. So you would set this one up as 29 over sine of 65, and then multiply both sides by sine of b, and that'll give you a little b. So you can see you're doing the same thing, right, in both cases. The only difference is your b is going to be different in both angles, so that's how you're going to get two different answers for this distance of b. Okay? Now, I don't want to show any more work, right? I don't want to work through these numbers because the rest of this is really just plugging this into a calculator, right, and getting a number. That'll be your angle, so that'll be angle C. Then this will just be 180 minus that and blah. So I'll leave the rest of that work to you. But that's all you need for this. That's how you set it up, right? And this is what we want to do with all word problems, is draw a picture, and then if we have to, keep drawing more pictures until we can kind of focus our thoughts. And then it's just which tool works for this situation. And this situation, because we've got a matching pair of an angle and its opposite side, we can use the law of sines. All right, hope that helps.